But we got to figure out what kind of vector are we going to use? What direction will we use to represent it? Curving along the edge, along the path it follows, that's a curved line, and vectors are straight lines. So that's not a vector. I couldn't take the velocity of any one point on the disk because it's got different speeds at different points and every conceivable direction. So really, the velocity of any given point is not an acceptable value for the angular velocities vector. What we need is something that is unique to all of these. Well, it turns out that every last one of these vectors every last one of the velocity vectors is perpendicular to the line that goes in and out of the middle here. Okay, it comes out of the page from the middle, goes into the page in the middle. Everything along here, every velocity is perpendicular to that. So that line would make a good starting point for a direction for omega. But we also need one more thing, because that line has two directions. It has out of the page and into the page. Similarly, this object can rotate in two directions. It can rotate counterclockwise or clockwise. Well, it turns out we define the direction of angular velocity based on a rule with our right hand that I'll illustrate in a video. But basically, you let the fingers of your right hand curve in the direction that the object is rotating, and your thumb will naturally point in the direction of the angular velocity. Which means, if I view something from the top and it's rotating counterclockwise, the angular velocity will come out at me. Similarly, if I view it from the top and it's rotating clockwise, the angular velocity will go into the page. Here, it's rotating to the right in front and to the left in back. That's counterclockwise if I view it from above. That means the angular velocity points upward. Here, it's clockwise when viewed from above. Angular velocity points downward. I'll illustrate that with the right hand rule on a video in just a moment. As far as the direction of the angular acceleration, just as we had in the case of linear or translational acceleration and velocity, if the object is speeding up, alpha and omega are in the same direction. So if it's getting faster and faster in the counterclockwise direction, then alpha is also out of the page. But if it's slowing down in the counterclockwise direction, alpha is into the page. Similarly, if it's getting faster and faster in a clockwise direction, that means alpha and omega are in the same direction. Omega is into the page, so alpha is into the page. If it's slowing down clockwise, then alpha and omega are in opposite pages. Omega is still into the page because it's still moving clockwise, so alpha has to be out of the page.
So now I want to discuss the direction of angular velocity. We can't simply say that as the wheel spins, it's spinning counterclockwise, because if we bring the camera around from the other side, keep the wheel spinning, when the camera comes around from the other side, you can see that from this point of view, it's rotating clockwise. So counterclockwise and clockwise are not a good enough description. Instead, what I'm going to do is I'm going to use my right hand. The fingers on my right hand have a natural pointing direction from the knuckles to the fingertips. That's how you use your finger to point. And they have a natural curving when you try and grab onto something. So what we do is we allow our fingers to curl around, pointing in the direction that the wheel is spinning. So you see my fingers are curling around, pointing in the direction that the wheel is spinning. And my thumb will then point out from the wheel. So we say that the velocity, the angular velocity, points along the axis, the one direction that is unique for this whole spinning, points along the axis, and then I use this right hand rule, letting my fingers curl in the direction the wheel is spinning, and the thumb points the direction of the angular velocity. This way, even if we look at it from the other side, I still, if I have my fingers pointing in the direction of rotation, my thumb will still point the same direction as before. It's away from us now because we're looking from the other side, but it's still the same direction in space. One last thing, I want to talk about why positive counterclockwise is considered the positive direction. Typically we say positive x is to the right, positive y is up, and positive z is out of the page. The reason is that I put my fingers in the direction of the x direction, hold my hand so that I can naturally bend those fingers to the direction of the y direction. My thumb will point in the direction of the z direction. That's the positive z direction. If something is rotating counterclockwise, I curl my fingers in the direction of rotation. My thumb points out of the page in the positive z direction.